All right, forget your apron for a second. Think lab coat. Because today, we're not just baking, we're diving into the science of it. We're going to find out what really happens when you turn simple stuff into an amazing loaf of bread.
I mean, think about it. It's something we totally take for granted, right? You've got this dusty flour, some water, and poof, suddenly you have this warm, fluffy, incredible thing. How? Seriously, how does that work? It feels like magic, but trust me, the science behind it is way, way cooler.
So let's pull back the curtain. This isn't some magic trick. It's actually all about chemistry and biology. A whole bunch of reactions have to happen in just the right order. Every ingredient plays a part, like a domino tipping over the next one, until you get that perfect loaf.
And here they are, our cast of characters. You've got flour, salt, sugar, yeast, and of course, water. It's like they're all actors in a play, and we're about to see what each one of them does when the curtain goes up.
Okay, so let's introduce the star of the show. No question about it, it's the yeast. And here's the crazy part you have to remember. Yeast isn't just some random powder. It's a living thing. A tiny, single-celled fungus, basically just hanging out, waiting for its big moment to do what it does best.
So, we've got our star performer, but it's asleep. How do we get this whole thing kicked off? Well, the first step is all about being its alarm clock. We've got to create the perfect conditions to wake that yeast up and get it to work.
And enter the lukewarm water. It's not just there to make things wet. Its temperature, that's the alarm clock. It's got to be just right, kind of like a spa for the yeast. Too cold, it just hits snooze. But too hot, you'll kill it. So that lukewarm part is absolutely crucial.
All right, so once the yeast is awake and happy, it gets hungry. And what does it want to eat? Sugar. It absolutely loves the sugar we've put in there. So it starts munching away, and this whole process is called fermentation. And as it eats, it burps out two really important things. Carbon dioxide gas, that's the key to making the bread rise, and a tiny bit of ethanol.
And here's a super cool thing you can actually feel. This whole fermentation reaction, it creates heat. It's what scientists call an exothermic reaction. So next time you have dough rising, just put your hand on it. You can literally feel it getting warm. That's the feeling of millions of tiny living things working their magic.
Okay, now for the part that really, truly looks like straight-up magic. Bakers call it proving or rising, but really all we're doing is getting out of the way. We're letting those little microscopic workers do their job. So what do? It's actually pretty simple. You just mix it all up, knead it for a bit till it's nice and smooth, then you cover it, and you walk away for about an hour. That's it. But while you're gone, that's when the real action is happening, deep inside the dough.
You know that whole kneading thing? It's not just to mix the ingredients. What you're actually doing is building something. You're developing these long, stretchy protein strands. That's gluten. Think of it like you're creating a giant, stretchy net inside the dough. Or even better, millions of tiny balloons. Why? Because that's what's going to trap all the gas that the yeast is making. Without that gluten net, the gas would just float away, and your bread would be flat.
And here's the payoff. Just look at this. Before, you have this small, dense lump. But after an hour, whoa, it's like it's come to life. It's nearly doubled in size. And all of that puffiness, that's just millions and millions of tiny gas bubbles, all caught in that gluten net we worked so hard to build.
All right, so we've built the structure, we've filled it with gas. Now it's time for the final act, the big finale. We're heading into the oven for the last, most dramatic transformation.
And that temperature? It's not just some random number you pick. 190 degrees Celsius, that's the sweet spot. That's the heat that's going to set off the very last chain reaction to lock everything in place and finally turn this thing from dough into real, actual bread. And just like the temperature, the time is super important too. About 30 minutes is what you're looking for. That gives everything just enough time to finish its job, the structure gets set, and you get that gorgeous golden brown crust we're all after.
But wait, there's one more surprise. The rising isn't over yet. The second that dough hits the heat of the oven, all those little gas bubbles we trapped, they expand like crazy. It gives the bread one last big puff upwards. Bakers have a great name for it. They call it oven spring, and that is what creates that perfect airy texture inside.
And here it is, the proof, the evidence of everything we've just talked about. When you finally cut into that loaf, you see all those little pockets and holes, right? Every single one of them is the ghost of a gas bubble, created by our amazing little yeast friends.
It's like a picture of the whole scientific journey, right there in your slice of bread.
So, when you think about it, every baker is really part chemist, part biologist, right? They're just controlling a scientific experiment to get a delicious result. And it kind of makes you think, doesn't it? The next time you eat a piece of bread, are you just having a snack, or are you eating a science experiment? And what else in your kitchen is secretly science in disguise?